Hey, how's it going, everyone? Welcome to homework number 4. So this exercise is called Wholemeal programming, and there are a couple functions that we're supposed to clean up and write in a more idiomatic manner. Wholemeal programming, I'm not exactly sure what that means. I guess it defines it right here. Breaking each function into a pipeline of incremental transformations to an entire data structure. So that sounds to me like kind of what I've been doing a little bit in this series so far, which is expressing things in a point freestyle. So let's take a look at fun 1. The problem with this function is that it's confusing and it is very low level. We're doing explicit iteration, so to speak, which usually can be represented with something like a fold or a map or whatever. And we're doing some conditional logic, which is fine, except that in the otherwise step we're literally just ignoring the current x and operating on the tail. So that sounds to me like it should be a filter. Anyways, let's get started. Define fun1 tick. So the first thing I just noticed is that in the case that the head of the list is even, we do one thing, otherwise do something else on the tail. So that bit can be represented just by a filter even. After a filter even, we're basically just applying this function to every element of the list. So what is happening here? Well, first we subtract 2 from the element, and then we multiply that to the result of calling the same function on the tail. So calling fun1 on the tail is going to, of course, do the same thing, which is subtract 2 from the head and multiply that by calling the function on its tail, and so on. So you can see that we're subtracting 2 from each and every element in the list. And that is what map is for. Okay, so we can sort of... I'm going to copy this function just so I can rip it apart a little bit. Right now we have a function that basically we want to emulate this behavior now. So we've subtracted 2 from every argument. All we're doing is taking the head and multiplying it by applying the function to the tail. So you can see that this is just going to expand to 1, 2, 3 goes to 1 times 2 times 3 times empty list 1. That's the base case. And this looks a lot like a fold to me. We are folding with the asterisk function with a base case of 1. Get rid of that. Get rid of this. And try compiling. Okay, it compiles. So before I test it, I want to mention that a fold R of asterisk, or a fold L actually, with 1 as a base case, that's already in the prelude, and it's a function called product. Much like sum, much like sum is a fold of plus with a base case of 0. So how am I going to test this thing? Well, this seems like a good time to introduce a little automatic testing library that is super awesome called Quick Check. I'll show you how it works really quickly. So, I could manually try to figure out what this function does and run some test cases on various random inputs. Let's see, fun1 on 1 to 10. 0. Oh, because I'm subtracting 2 and multiplying. You know, and then compare that to my function, try another case, compare it to the original, and so on. Quick check is perfect for this. Quick check. And this takes a function that is a property, and property returns a Boolean. So I take in some list, and I want to assert that applying fun1 to this list is equivalent to applying fun1 tick. And it works. It randomly generates 100 tests, and it tests all kinds of edge cases like empty lists and negative numbers and all kinds of stuff. If I want to increase that number, I can use a different function, quick check with, which takes an args struct. Standard args is the arguments you get with just calling quick check, but I can modify the what is this field called? Successes? Runs? Max something or other. Max success, there we go, equals, let's say, 1,000. Run it again, just to be sure. Let's try 10,000. Okay, so we can be reasonably certain that the function I wrote does exactly what the original function does in a much cleaner and idiomatic style. I think that's enough for this episode. I guess I could try tackling this one. For this problem, you may wish to use the functions iterate and take while. I think I'm going to end this video here and do fun2 in the next one. Alright, thanks for watching.